Assalamualaikum, hello and good day to all. My name is Siti Artasha binti Suhaimi. I am a 4-year student of Chemical Engineering at Universiti Teknologi Malaysia. In this video, I would like to present about my individual assignment of membrane-based gas separation technology course. For this assignment, I need to give some comments based on the 5 publications in open literature based on the topic preparation and application of stimuli responsive membrane. So the first publication is Stimuli Responsive Membrane by D. Wanderer et al. The author reviews various methods in preparing the membrane from stimuli responsive materials, which are radiation-based method, solvent casting, interplanetary polymers network (IPNs), and phase inversion. These suggested methods were approached based on the desired design of responsive membrane, such as its mechanical properties, pore structure, barrier structure, and layer thickness, which are very important to enhance membrane performance. The developing field of stimuli responsive membranes and its importance were well explained by the authors. They stated that the responsive membrane system will stay relevant as it will move towards advanced functions and have strong potential for future applications in bioseparation, tissue engineering, and more. For the second publication, it is a synthesis and application of stimuli responsive hyperbranch polymers journal by Wang et al. Wang et al. Greatly emphasized the studies of stimuli responsive hyperbranch polymers (HBP) with various categories on the synthetic approaches. One of them is polymerization from stimuli responsive monomers. For this approach, the chemical structure of a monomer is altered during polymerization, yet the resultant HBP is capable to preserve stimuli responsiveness as long as the stimuli responsive functional groups are still influenced by internal or external factors. Then, the authors also elaborate more detail about design and preparation from different sources, and it highlight the most crucial part for preparation of responsive HBP is the selection of static monomers. Also, Wang et al. Firmly believe that the stimuli responsive HBP will play an even increasingly significant part in the field of specially designed functional materials. However, there is no doubt that there still exist a lot of issues that urgently need to be solved. Next, for the third publication is the preparation and characterization of stimuli responsive hydrophilic polysulfone membrane modified with poly and vinyl caprolacram co-acrylic acid journal by Sinha et al. This is an interesting study in which the authors have made findings related to the performance of novel polysulfone PSF ultrafiltration membranes with pH and thermosensitivity using the selected copolymer. Sinha et al. Did highlight the importance of pH and thermoresponsive materials as they mainly focus on the preparation and characterization of the dual responsive membrane using pH and thermoresponsive copolymer. As the author stated that pH and thermoresponsive properties will be important in various separation and purification technologies. Next, the authors also investigate the permeation and anti-fouling performance of prepared membrane, and they noted that the selected copolymer also increases the hydrophilicity of the membrane as PAA contains carboxylic group. Due to the hydrophilic nature, it can improve the anti-fouling property of the membrane. Application is the stimuli responsive mixed matrix polysulfone ultrafiltration membrane for humic acid and photocatalytic dye removal applications journal by Singh et al. Singh et al. Presented a very valuable information related to the study of TiO2 and nanoparticles with pH and temperature responsive polymers by blending method. This method is a perfect choice because it is one of the most effective and efficient method for the modification of membranes. In addition, it also assures the stable and proficient addition of the desired property into the membrane. On top of that, the authors accentuate the pros of using the selected polymer will help in improving the membrane selectivity, permeability, and anti-fouling properties. Next, this study also successfully proved that the prepared membranes are significantly anti-fouling in nature because of its 97.7% HA rejection. The authors also affirmed that membrane fouling is a serious problem associated with membranes, which declines their overall performance and therefore required to be kept at minimum. This is the fifth publication, which is the Stimuli Responsive Membrane Smart Tools for Controllable Mass Transfer and Separation Processes by Yang Yin et al. So, the authors greatly emphasize the technology of smart membrane, which is very fascinating in my opinion. In this paper, the bio-inspired design of environmental stimuli responsive smart membranes were introduced with their own essential elements, which are their responsivity to the environmental stimuli, its stability, their reversibility, and lastly, the reproducibility of smart membrane materials. In this study, the selected polymer chosen by Yang et al. Is poly and isopropyl acrylamide (PNIPAM) because it shows a distinct and reversible phase transition at lower critical temperature. DCD molecules that appended with PNIPAM chains possess hydrophobic cavities and hydrophilic external surfaces that capable of selectively associating with gas molecules having a similar size to its cavity, and is used widely as the chiral selector in inertial separation membrane. In my opinion, its application is very relevant to membrane technology nowadays because of its high efficiency, low energy usage, simplicity, and continuous operability. and has been considered as the most potential method for large-scale inertial separation processes. That's all from me. Thank you.